the Power BI for Enviro meetup sessions available afterwards on our blog and YouTube channel. Awesome. So welcome everyone. Thank you for joining us today to Power BI4Enviro's. If you're a new kind of member to our group, thank you for joining. And I can see we've got a couple of regulars here dialing in as well. So thank you everyone for coming back. Intro into our group. Our mission is really to share different case studies, learn new tips and tricks, and empower other environmental professionals on their Power BI journey. A bit of housekeeping. I think everyone's well and truly used to the virtual environment these days. But if you haven't, please use the Teams app for the best experience. Please just make sure you're on mute when you're not speaking. If you have any questions, I think Matt wants this to be a fairly informal and kind of dynamic presentation. Please feel free to go off mute and ask your questions or type them in the chat, and I can help moderate the session as well. So as I mentioned, this session's being recorded and we'll share it after on our YouTube channel and through the meetup group. And also a bit of a Teams tip, you can always zoom into the shared content from the presenter by holding Control and scrolling with your mouse. It's a little bit small as well. Before we begin, I'd just like to give a short acknowledgement of country. So we'd like to acknowledge the Boonwurrung and Bunurong people of the Kulin Nations, who are the traditional owners and custodians on the lands and waters at which I'm presenting today, but also pay our respects to the elders on the lands in which you're dialing in from or presenting as well. And just a quick shout out to our event sponsors, Discovery.ai. At Discovery.ai, we really specialise in Power BI for the environmental and water industry. And we do a whole lot of Power BI training and mentoring. We've got Daniel, who specialises in custom visual development, end-to-end BI reporting. We also do infographics and animations, and also just general environmental analytics within Power BI. So let's get into it. We've got we're really lucky to have Matt Allington here presenting today, all about his analysis in Power BI to track the recent floods across Eastern Australia. So Matt's a Microsoft MVP for the data platform. He's based out of Sydney, and he's joined us a couple of times, I think, already. But today he's joining us to share his Power BI report presenting streamflow data from the most recent floods, which have impacted a large part of Eastern Australia. And this is going to be really interesting. I think, as with any Power BI kind of study, especially if you're looking to get into Power BI, sometimes using a data set which is of relevant to you or is something you're interested in can go a long way to trialing and testing out different techniques for visualizing and analyzing the data. So Matt's been sharing regular updates of this Power BI report. It's a fairly kind of personal story about tracking the floods in a specific region where his family home is based. So you can catch up on all the different analysis on Matt's YouTube channel and also his blog. But without further ado, I might hand it over to you, Matt.
Yeah, great. Thanks a lot, Alice and Daniel. And yeah, thank you everyone for joining. Let me share my screen. As Alice said, I'm going to do a fairly casual session here, so I don't have any formal slides or anything prepared. And as Alice also said, this is a sort of a personal journey, if you like, for me, and I'll sort of show you a little bit about why that is. And so I'm fortunate to have a holiday house, a family-owned holiday house, belongs to my wife's family on the River Murray, and it's in a place called Big Bend. I'll just quickly show you where that is. It's in South Australia, so across the border. Across the border, sort of you go through Renmark. This is it here. So you can see that here's Mildura, Renmark. So the River Murray sort of comes up along here, comes up, it peaks up at the top of South Australia, and then it heads down again, and then heads down towards the Coorong. So we're here at Big Bend, and it's a unique part of the world. We're very lucky to have a holiday place there. It's very modest. I just want to show you a couple of photos to give you a sense of what we're dealing with. So this is an old photo of our shack. So it's literally a shed. It's a shed. We've got absolute water frontage. But this is the normal water level that I'm showing you here. This is January 2017. And so this is what we would call the pool water level. And you can sort of see the contour of the land here and the grass and everything up there. So I'm trying to give you a sort of sense of how much water we've got coming down at the moment. Now, this is a photo of our jetty. So now standing on the bank, looking back down. And once again, this is pretty close to the pool water level. So that's reasonable. And we've actually recently put this jet ski dock on our jetty. You can see the water level here is a bit higher. And in fact, these poles are so basically these are 1.5 meter poles. And as a result of this flood, we've actually added another 1.5 meters on top. So we've basically got 3 meter poles on top of our jet ski docks at this point in time. And I want to show you the photo from yesterday. So this is, let's see if I can get a better one. This is it here. So this is our holiday house from the river, and this is the jet ski dock. Now you can see, you can't see any poles, and that's because the poles are 4 meters below the water. So this is hanging on by dear life, this jet ski dock. It's basically risen 4 meters. So there's 4 meters of incremental water above the normal flow at this point in time. And you can, it's sort of, if you have a look here, you can see we don't have a lot of capacity left. We're going to be basically going under in probably about a week or so. But and so really the presentation today, this report that I've built, is really designed to help me track what's going on with the water from upstream and try and understand what's going on. So I'm going to sort of share some stuff. I'm not going to go into everything that I've built in this report, but I want to give a mixture of the journey that I've been on and how I've evolved this report to be able to meet the purpose that I had in hand, which is to understand what's going on. Very much when you build a report, these things tend to be circular in nature. They're not linear. When you're doing an enterprise grade business intelligence project, you may start off with some user requirements and documentation, user specs, technical specs, and then you build the solution. But typically in the world of self-service BI, it tends to be much more fluid, where you sort of head off on a journey and you learn as you go. So this front page was really just my starting position to try and understand what was going on. I haven't really spent a lot of time thinking about the other river systems that feed into the Murray. So we're about here at Big Bend. But if you come and have a look upstream, we've got the Darling River upstream, we've got the River Murray upstream, and then sort of coming in around here somewhere, we've got the Murrumbidgee River. And so I sort of started off with this map of Australia and then started to dig into some much more specific data sources. And so this image on the right here, I've actually picked this up from a few different websites. In fact, this particular image has come from this website here, which I'll just throw up on the screen at the moment. So in order for me to keep track of what's going on, I've had to find different data sources. As you can imagine, we've got New South Wales water, we've got Victorian water, we've got SA water. All of these different organisations have data which is of relevance to me when we get down towards the bottom of the River Murray. And so, as you can also appreciate and imagine, every provider of data has a different way of doing things, right? So this is actually a very interesting problem that many of us have to solve with Power BI reporting, and that is that we get data from source A, we're getting data from source B, source C, and the data look very different to each other. And so one of the very important roles you play when you do this sort of reporting is to harmonize and standardize the data from different sources in such a way that you can report on them together. So I'll just sort of do a quick overview of some of the main reporting pages that I've got and the way this has evolved. So if you have a look at these black boxes here, I took the inspiration from this page here, right, which is a system view of the Murray-Darling system. So rather than worry specifically about where the ebbs and flows and where the bends are in the river, what's more important is to understand directionally where the data, in this case water, is coming from. And so I've used this concept to build myself a system map, saying that, well, South Australia, this is where the water enters South Australia at this point here. And so this is a data point specifically called flow to South Australia. And so what I was able to do for all of these black boxes was to go back in time and grab data from different flood years and present those data on this screen, so that when I'm looking here and I can see that as of today, we've got 162 gigalitres per day coming into South Australia. How does that compare to the flood back in 1974? And so the 74 flood, for reference, Ash Shack, the pictures I showed you before, went 50% under. So it was about 1.2 meters underwater. So, and we're already at 162. So this is looking pretty bad. And I'll sort of show you some more details about that. But then, so as I go upstream, what I'm trying to do, or what I was trying to do here, was get an early warning understanding of what's going to happen here, because this is the one I care about. I care about how much water has gone through Lock 1. So on the River Murray, Lock 1 is the last lock before basically the barrages at the mouth. So once the water goes through Lock 1, there's no holding it back. There are some barrages actually, but there's no more locks to hold back the water, and we're just below Lock 1. And so basically, as you go upstream, literally swim upstream, there's this water coming into South Australia. Before it comes into South Australia, it comes into Lock 10, but there's this opportunity to divert the water into Lake Victoria. And this is one of those examples of where I learnt as I built this chart that in this case, it's the Murray-Darling Basin Commission, actually has been siphoning water into Lake Victoria. And so I started keeping track here. If you go right back in sort of early November, you'll see that they were basically taking 5 or 6 gigalitres of water per day into Lake Victoria, letting very little out. And that was having the effect of filling Lake Victoria up. And so as I was tracking this over the last weeks, I noticed that they actually stopped taking water into Lake Victoria and they started letting water out. And so my assumption was they were running the lake down in order to create some capacity so that when the peak flows came at some point in time, they were able to take more water in again. And now you can see that they've started to take water in again, but they've sort of backed it off now. So really, this is the main page that I look at. Just a couple of features. I've put these tables so I can see what's going on. I put some conditional formatting here showing the change in flow from the previous day. So green meaning that there's been a reduction in the flow, which suggests that it's peaked. Red meaning that the change in flow versus the previous day is increasing. I've also added these little sparkline objects. I think these are OKViz sparklines because you can take a step back and have a snapshot view of what's going on. So you can see that there's a couple of key data points here. The peak was 167 gigalitres per day. That's the green dot. And then this 155 is the current flow per day. So there's a lot of information here. It tells me that the water has been flowing at or near peak for some time. And if I want to find out how much time, I can sort of go down here, come down to this one here. 167 was the 13th of November, and we're now the 13th of December. So it's basically been pretty close to peak for about a month now. So a lot of water coming down from Wackle Junction. The next thing I did was I decided to add these data sources together. So there is no such concept of the Wackle Junction and the Murrumbidgee water combined, but I just literally combine those two data sources together to give me an early warning of what's going to come down into lock 15 and then ultimately come down into lock 10. And as I've been tracking this, what I've increasingly realized is that the water is becoming additive. So this 53 and 167, even though these are peaks, almost all of that's been added together, and we're getting 217 gigalitres a day out of a maximum possible 220. So a lot of water coming down. Then we have to add the 17 gigalitres from the Darling, getting up to 238. And you can see that as of today, lock 10 is at 229 and it still hasn't peaked yet. So I've got no reason to think that we're not going to get pretty close to 230 gigalitres per day hitting lock 10. If it hits lock 10, yes, they can take some water into Lake Victoria, but they've only got 100 gigalitres of capacity. So if they take 5 gigalitres a day off of the peak, divert it into Lake Victoria, they can last for 20 days. And if I go back here, you'll notice that there's 30 days worth of water coming down. So I'm not sure that that's even going to be enough to make a difference. So I've basically been tracking this now over many, many weeks, and this number has basically been flowing down. And I'm now expecting that this one is going to get pretty close to 230, which is going to be way out of the park compared with 74. So for me, the future is not looking that good for us on the riverfront. There's a few other reports here. As I started to try and get an understanding of what's happening further upstream, I started looking at the other data sources. And so I found this data map, which was being updated by a third party. And so I was able to embed that map in here. And then I've created some more of these spark lines. So this is quite disturbing when I first looked at it, that even though the water I'm looking at the moment, and I've just been showing you, is around 230 gigalitres coming into South Australia, there's another peak upstream up at Burke, and I'll show you that a little bit more closely in a moment. But there's another massive amount of water upstream, although that's come off now quite a bit. You've probably heard about the floods in Forbes and also in Narrandera, so they've had their own problems along the way. So just another view of the data. This makes less, this is of less value to me today, this particular page. But if I go back 4 weeks ago, this was certainly a lot more relevant because I was trying to get a picture of what was happening upstream. I've got 4 other views here. These are of separate river systems where I look in a little bit more depth. And so just notice what I've done here. I've obviously pulled the data from somewhere. I'll show you that briefly in a moment. But what I decided to do was to find some strategic data points along the river. Notice that I've just grabbed the map off of the web and pasted it in here. And then this is using small multiples down the bottom. What I'm trying to do is keep track of where the water peaks have come from. So, excuse me. So you can see here that we had a peak at Burke. One thing I did to try and make it easier to work out how long does it take from the water to go from one location to the other. Well, to do that, I really need a peak. You need to have a turning point so that you can work out where the peak was and when does the peak flow downstream. Just excuse me for a second. Oh, I should have got a glass of water. So one thing that I did on this small multiples chart was I put the day of the year. So you can see here that this peak was on day 328. What that enables me to do is just much more easily come in and do a subtraction. So 337 and what was it, 328. So you know, like 10 days orders of magnitude between those peaks. So now I know that it takes 10 days from the peak to get from Burke down to Louth. And there's another important observation here, and that is that the peak was 202 gigalitres a day in Burke, whereas it's only 150 gigalitres a day or thereabouts. Maybe it's a bit more than that here, 190 gigalitres a day in Louth. So, these differences in peaks are important. And one thing that I've, I guess, assumed as a result of my analysis is that as the water goes down the stream, depending on the contours of the river, the amount of backwaters, some of this peak flow will get sucked up, if you like, or sucked out into the flats and then come back into the main river system down the track. When we get to this Tilpa point here, you can see that the peak's down to 132. So when I first saw this peak of 200, I thought, my goodness, that is a massive amount of water. Imagine when that smashes into the Murray. But the reality is, because of the contours of the land, that 200 gigalitres a day is never going to hit the Murray all at once. So I've got one of these for the Darling. I've got one for the Lachlan. The Lachlan was even more responsive to the geography. So there was this Wyangala Dam where they dumped a whole lot of water as a result of the dam being full, and then that flowed downstream and hit Cowra and Forbes. You can see that they've had 2 or 3 different peak events here that have caused them to flood. But very quickly, that water has dissipated. I mean, it's not good if you live in Forbes. Clearly, we feel sorry for these people that are affected. But once again, what I've learned from this analysis is that these peaks of flow in some of these towns is not going to be additive. It's not going to all flow down, and we're not going to add 100 gigalitres from Forbes to 200 gigalitres from Burke and so on, and end up with 400 or 500 gigalitres down the bottom of the Murray. So jump over to the Murrumbidgee, same sort of thing again, just looking at analysis of the different peaks to try and understand how that's flowing through. A couple of other things that I tried to do at various stages. So what I've done is I've created these overlay maps where I've taken different data flow points. So if I go back to one, these are just bookmarks that I've got down here. So if I go back to the 56 floods, you can see here that I'm able to have a look at what happened at Lock 15. So this dark blue line is Lock 15. One of the features of some of the older floods is I don't have as much data. And so I'm sort of having to rely on one of the particular data points. Perhaps I might just jump over here to the flood years, because this is probably a better way of looking at this. So if I have a look at Lock 15, you can see here this black line was the 56 flood, and this red line is the 2022 flood. So you can see that at this stage, at 2022, 74, that was the year that we went under. Notice that we're already above the 74 flood levels at Lock 15. And once again, here's these little thumbnails that I keep putting here. It's just to help you understand what this means. So Lock 15 is picking up the water from Wackle Junction and Murrumbidgee, but you've still got to add the water in from the Darling. Now, when you have a look at what happened in the Darling back in 56, there was a stack of water coming in from the Darling River being added to the water in Lock 15. So it's just different ways of looking at it. But to me, this is a clear indication that the 2022 floods are going to exceed what happened in 74, because we've already got more water at Lock 15. That's before we even add in the 17 gigalitres a day that's happening from the Darling River. There's a couple of other things that techniques that I used, and then I might show you some of the tips and tricks I used to actually build this report. This is a new page which I built. I think I did this just yesterday. And what I'm trying to understand now, as we get closer to the flooding event at the lower Murray, is I'm trying to understand how long is it going to take for the water to flow downstream. So maybe I don't have a little thumbnail. Just let me come back to the system map first. So what I'm looking at now is Lock 15, Lock 10, the flow to South Australia, and Lock 1. So these basically the 4 data points I'm going to look at on this new report that I've created. So if we have a look at the SA timing, you can see here that lock 15 is currently at close enough to 217 gigalitres a day. And by the time we add in the Darling, we're up to 230. So lock 10 is already at 230 gigalitres per day. So that's this dark blue line. But it's a bit hard to tell when you look at this, these three lines overlaid, is how long does it take for the water to flow downstream. And so what I've done here is I've created these little sliders, which are basically time intelligence adjustment tools. And so what I'm able to do here is I'm able to drag the light blue line to the left. And so what I'm effectively doing is I'm putting a delay, and I'm saying, if I was to assume that there's a 9-day delay between lock 10, the dark blue line, and the blue line, which is the flow to SA, assuming there's a 9-day delay, you can see that those lines much more closely overlap with each other. Now, it's not perfect because there's all sorts of things that are happening. There's releases of water, there's different wetlands out to the horizontally soaking up the water. But you can see that this looks like a reasonable approximation. To me, it says whatever happens at lock 10, about 9 days later, that appears to happen in this data point called the flow to SA, which is where they measure the water coming onto the over the border. Now, notice that this is flattening out a little bit here, but also notice that there's a bit of a flattening going on here as well. And so, to me, I would expect to see some reduction in flow coming from lock 10 to SA. I could go back to a previous year to see what happened. So if I went back to 93 was a reasonable flow, nowhere near what we're having this year. But if I go back to 93, notice that the peak into SA was 111, whereas the peak at lock 10 was 140. So, there's a 30 gigalitres a day difference. Now, I don't think we can assume that exactly the same is going to happen this year. I think the ground is much wetter, generally speaking, in South Australia this year than it was previous years. So as the water flows, if the ground is dry, it will soak up a lot of water. I think the ground is quite saturated. So it's just my opinion. I don't have anything to back this up, but I think there's going to be a much smaller gap. So instead of there being a 30 gigalitre reduction flowing to SA, I think it's going to be less than that, but it remains to be seen. So it looks to me, I come back to 2022, it looks to me like orders of magnitude, a 9-day delay. So 9 days after it goes through lock 10, we should see it flow into SA. And if that's true, we should expect to see around 220, something like that, by by Christmas Day, basically, or a little bit after. And then I've got this other delay on lock 1. So how long does it take to get from lock 10 down to lock 1? And I can just basically do the same thing. I'm just sliding that chart across. Notice the little humps here. See how I can sort of almost align those humps? And this is it's good to have a turning point in the chart to be able to see how to overlay them. So if I line up the humps, you would say 22 days. But if I take into account trying to line up the lines here, and based on my experience of looking at this data, I think this is a better fit. Excuse me, because as the water starts to rush through, it seems to pick up speed, and so I think there's 27. So basically a 4-week delay. And if that's true, then I would expect lock 1 will peak at around about the middle of January, so 10th of January, something like that. And so, look, that's my analysis. SA Water gives its own analysis on what it thinks is happening. And but I just look at the data and see what and report what I see. So look, I might just take a breath for a minute and see whether there's any questions from anyone based on what I've mentioned so far.
Yeah, thanks, Matt. Yeah, it's been really, really interesting example, and it just shows the power of Power BI to users, almost like a back of an envelope analysis tool. There's so much you can do without going over the top, writing tricky DAX and things like that, just in the visuals. At this stage, I don't think there have been any questions, but I might just open it up to the group, give a minute or two if people wanted to go off mute and ask any questions at this stage.
That's why we're waiting to see if there's any questions. So I might just go back and share my screen again. But one thing I meant to mention, and I actually didn't get around to doing it. So we talked, Alice made a comment about the small multiples chart that I showed. So for each of these, I had these small multiples. One of the benefits of small multiples is that they're proportionate, right? So they're just, everything's to scale. And I actually use that same technique over here. So even though these are spark lines, what I did with these spark lines was to set the scale for all of the spark lines to be the same thing. And so that way you can see that Darling, this 17 gigalitres a day coming from the Darling is nowhere near as impactful as this 156 gigalitres a day coming in from Wackle Junction. So getting those scales correct is actually a really important feature when you're trying to communicate to people what's going on. So the whole idea of these reports is to give people a snapshot view, hopefully using imagery rather than numbers, because it's much easier to consume imagery, and getting those scales correct is an important part of that.
Yeah, 100%. I did have a question, which I think might be interesting for the group. If you go back to the essay timing page, it'd be really interesting if you walk through how you created that kind of dynamic scenario analysis, because I think this is something that super powerful in Power BI.
Sure. And the good news about this one is that it's not super hard to do. And so let me show you that. It's a good example. So what I might do, let me just go to, I'm just going to duplicate this page if I can find it. And I'll sort of take you through the journey that I went on. So first of all, I've got measures for each of these things that I'm trying to measure. So I've got one for lock 10. So I've got various, you can see a lot of measures here. So I've got one called lock 10 flow in gigalitres. And then if I bring flow to SA, I've got another one, and I'll just bring in lock 1. And I'll show you these measures in a sec. So lock 1 flow. So if I just take the lock 1 flow, so this is just a simple measure. I've got a generic measure that is just the flow. So let me perhaps show you my data model. This might be worthwhile doing. So it's actually a relatively simple data model. I've got some disconnected tables here used for various things. A lot of these are parameter tables. So Microsoft recently introduced this new concept of parameter tables. They're really useful. I'm using quite a few of those. But if you look at my data model, if this one here is a technical table, what I might just do is I'll quickly I'll show you basically this is my data model. So there's nothing really more to it than that. One of the beauties of DAX is if you can get your data model right, then the DAX becomes much easier. And so in this case, I'll show you what my data is. So the data it's a transactional table. It contains the date of the observation. So my data is observations or are observations. And the observation has a value. So if it's a flow, it's gigalitres per day. I also observations for water level. So that would be meters in height and so on. I've got an index, which is my key. So I'm using that to reference back to my dimension table. And importantly, I've also decided to keep a source column. And one of the features I mentioned before is that because I've got sources from New South Wales, from Victoria, from South Australia, different websites, I've got spreadsheets that people maintain themselves. What I decided to do was to keep track of where the data had come from to help me in the case that I had a problem. Now, I want to go back and do this time intelligence function first, but I might come back and talk about this a little bit more. But this is a very simple data model, and And so if I come back here and have a look at my, say this one here, the flow to SA. So all I'm doing is I'm adding up the data point, which is the flow in gigaliters, and I've got this named location. What I decided to do was I created these named key pairs, and probably makes sense if I show you this table here. So this is the dimension table. This table contains every single location where an observation occurred. And so if I come down here and I go to flow to SA, so this is the observation that we're looking at. It's the flow to SA, and I've got a unique key, a name that I can use in my formulas. This name never changes, and this is its name. It's a flow observation. It's in megaliters per day, and so on. So okay, so when I put those three on here, sorry, at this point in time I can't control anything. And so what I want to do, if I want to move one of these lines left or right, then it's effectively a form of time intelligence. And so I've got a one here called lock one delayed, and I'll show you this formula. And it's just a time intelligence calculation. So, so the way it works is, actually, yeah. So the way it works, if I say, write this formula, so calculate the flow to lock one in gigaliters, but I'm going to use this time intelligence calculation. It says date add. So date add is a time shifting calculation. So the way to read this formula is calculate the flow in gigaliters to lock one, but before you do that, I want you to do a time shift. I want you to do a time warp. I want you to go back in time 7 days. All right, so when I write that formula, you'll see, I'm going to get rid of these other ones. So now I've got the light blue and the dark blue. So the light blue is the original reading and the dark blue is the one with the adjustment. So I can hard code this. So change it 14 days, right? Change it 28 days. And I can go back and forward, right? So I'm going back in time. So I'm moving the original data, effectively I'm moving it across to the right, but I'm making this change, this time intelligence movement. But I don't want to have to hard code that number, right? Because if I hard code the number, it means when I publish it to the web, I can't make any changes. If I want the user to have a user interaction, then I need an alternative approach. And so that's what I'm using here is a parameter. So what I did was I came up here, I went up to modeling and I said, create a new parameter being a numeric range. And I'll give this will be my test time shift. And my parameter will be a whole number. The minimum will be, this time I'll go minus 14 and plus 14. And I'm going to increment by 1. And I'll put the default as 0. So this is a wizard to help me complete the step that I'm about to complete. So I'll create that parameter. And what happens is I get this is basically a slicer. It is exactly a slicer, in fact. But I'll show you what's being generated. So this slicer that was being generated is actually on top of a table. So let me show you the table. So when I used that wizard, what happened was it generated a table. The table started from -14, it went to +14, and it increments by 1. So every number between -14 and +14. And if I come and show you this over here, this new table is not connected to anything. We call it a disconnected table. It's just a table that contains all the unique values from -14 to +14. And then this is a slicer that points to the table. The second thing I've got here, this is what the wizard did, was it generated this line of code. This is a measure, and the measure tells me which item is selected in the table. So if I bring, say, a card, let me add a card. There, I didn't mean to change that to a card. Let me go back. I'd rather change it back like that. Okay, let me add a new card. And I'm going to bring this measure into the card. And now notice that when I change this slicer, the card changes, because this measure here tells me what value. This measure tells me what value is selected in my slicer. So when I move the slicer, the card updates to tell me what number I've selected. And so I use this trick to instead of hard coding my calculation, I'm actually using this this slicer. So if I go into this delay, and instead of hard coding the number 28, what I would do is I would use this, what did I call it? Test time shift. I think it's that one there. All right, so basically I just place that measure, the number that coming up in the card, I place that inside my time intelligence function. And so then, where's my, so if I set this to 0, there's no time shift and the two lines sit on top of each other. If I go back negative, you can see that the delay shifts to the right, and if I move the other way, it shifts to the left. So this is a great way of doing interactivity, and in this case, it was in order to align my data points, but there are various other things that you can use this technique for. So Alice.
Yeah, awesome. Thanks, Matt. Yeah, that's just such a powerful technique, I think, especially for this type of analysis. So thank you so much for walking us through that. Sorry, I think you're still on.
I'm on mute. Sorry. How are we going for time?
I think we probably got another maybe 5 to 10 minutes to wrap up, unless there are any questions at this stage. Helen Kennett says that's really cool. Yeah, it's very cool, so powerful.
All right, so maybe I'll just show you a couple of my little tricks. And, you know, we all learn stuff through our journey. We learn from other people. I learn stuff from everyone that I come across. I remember having Alice come and talk to our user group one day because I just couldn't believe how fantastic her reports looked. You know, Alice has got the gift of making stuff look beautiful. The point is, everyone has got something to add, and go on a long journey and smell the roses as you go and learn from everyone as you progress in life, and you'll get better and better at Power BI. So I want to show you just a couple of little tricks that I used. I just made some notes as I was building this report, and I thought I would just share some of the techniques that I used on this journey. Now, I'm sure anyone that's had any experience with Power Query and Power BI would be used to consolidating data from files. So let me show you the raw data here. So if I come in here, so looking at this, these folders here, I've got these files. These are CSV files sitting in a folder, and I've done a file combine. Right, get data from folder, do a file combine, and when you do that, you get one of these sets of data, right? So this is the one for file combine SA water. This is the one for file combine for the barrage data that I downloaded. You know, this one is file combine from historical extracts. But if you look down my page, look how many of these things I've got. Now, I don't know, have you ever done this? And it's such a pain in the butt, right? Because each time you come in here, you have to come in here and you have to collapse all of these because you can't actually work out where you are. So you come in here and you collapse all of these, and you spend all this time. And if you're like me, I'm a bit OCD. I can't even concentrate if all of these things are open. So so you collapse all of those, and then you get out of Power Query, and then you go back into Power Query again. And when you come back in here, they're all expanded again. It's so annoying. So one just simple tip is to move all of your transform, all of these sets of files, these sets of file combined, create a new folder called, I just call it transform queries, move all of the subfolders into here. So it's not hard to do, right? So you can just come down here and do a new folder, a new group, sorry. So you come down here, new, maybe I'll come here, move to group. So new group, I can do move to group, create a new group, right? Test. Once you've created the new group, you can just drag these like this. You just drag them down into that group. Just drag them down. Anyway, the point is create a group. I called mine transform queries, and then you can click on this top group, right click, and select collapse all. And once you do that, it collapses everything. And so if I now expand this, they're all collapsed like this. I'll move these back up in here now. I just wanted to show you how to do that. So yeah, the point is probably, all right, so right click, collapse all by having a top level folder or group and collapsing everything. Then you can come and expand them and it's all nicely laid out on the screen. So that tip alone takes a whole lot of angst out of my life. The other thing I would recommend on these transform queries is that when you come into them, try and get used to renaming these. So this is what the default looks like. It says sample file, parameter 1 for sample file, transform file, transform. It's very generic. What I try and do is come in and rename those. Before moving on, come in and rename them so that each of these query steps has the name of the transformation. In this case, this is the barrage data that I'm transforming. If you don't do this, what ends up happening is that these names are very generic and it becomes very hard to debug your queries because they all have the same generic name. But by renaming them as you go, it does mean that it makes it a little bit easier. You can see, have a look at the difference here. See how similar these are to these? It's very difficult to actually determine what it is that you're talking about, whereas this one has got a better name. So that's a second thing that I recommend that people do. There is another technique which I'm not going to go into a lot of depth, but it's just a trick that that you can use. I'm going to show you this Excel spreadsheet. One of the features of Power BI is that it doesn't have any persistent storage. So if I was to connect my Power BI report, let me come back here. We'll go up to, I'll open up one of these pages here, like this one here. All right, so here's a web page. If I could connect my Power BI report to this page, and this page contains the data points for various locations, many of which I care about. So this is where I get the Wackle junction number here, this 152 gigalitres per day. But the trouble is when I come back to this page tomorrow, the data has changed, right? There's no persistent storage on this page. This page only ever shows me today's data. It doesn't show me yesterday's data. And inside Power BI, there's no persistent storage either. So you can't say to Power BI, refresh the page today, and then tomorrow, refresh it again, but keep what you had yesterday. You can't do that in Power BI. And so this is a technique that I actually built for the first time for this particular report. And what I did was I wrote a number of queries using Power Query for Excel. And I won't go into these. They were connecting to a web page refresh the web page, and then save the results of that query as a table in Excel, right? So now I've got an Excel file that contains the data that's been scraped from the website. But then what I did was I wrote a little bit of VBA code. I will probably do a blog article on this after Christmas. Haven't got around to it just yet. But what I did was, and not everyone is into VBA, I understand that. So one of the reasons why I will share this. But what this VBA code does is it takes the table, this one here, and it saves it as a CSV file. So every day what I do is I open up this workbook that's got some macros in it, and I'll show you now. I come in here and I click this refresh button. I might just do this one. I click this refresh button, and what it does is it refreshes the query in the Excel file, connects to the data source, and it's asking me to replace it because I've already done this once today. It refreshes that workbook, and then it goes and saves this sheet as a CSV file in a folder on my computer. And I do that every day. And so I've got 4 separate queries here that all get run. So this one button here refreshes all 4 tables in my Excel workbook automatically. It exports the results into a CSV file on my computer, and then it's basically permanently stored there. And if you have a look at the, if I have a look at, say, this barrage data, actually I need this one here. So these are all those CSV extracts that get generated every day. And then in fact, there's one more thing that you can do. And in Windows, many of you would know there's this feature called Task Scheduler. So Task Scheduler is one of the more deep technical tools that you can use inside Excel. But one of the things you can do with this Task Scheduler is you can open Excel at a scheduled time every day. And so that's what I've done. So I've created this. So I've got my Excel workbook that's got a macro in it. The macro, every time you open the workbook, automatically refreshes my 4 tables and exports them as a CSV. And then I've got this Task Scheduler that, this one here, that at a certain time, 7 a.m. every day, it will come in here and it will open, you can see here, it will open Excel. So it opens the program Excel, and it opens the workbook called List View Web Scrape Daily Auto Run, XLSN, and then it refreshes the macros, and then it shuts the workbook down again. And so basically what I've built is a automated refresh tool, which is completely separate from Power BI. And it sits, I've got a computer that's always on at my house, and it just sits there and refreshes every morning. And then I have Power BI set to refresh about 10 minutes after that. And yeah, it just stays up to date without me doing anything.
Oh, cool. I've never seen this this type of workflow in Excel before. Like, my question was going to be, can you automate it? Do you have to kind of manually open it up and click a button? But that's really cool. So you just need a computer to be on.
Yeah, that's right. So you get down this, you start off thinking, well, what if I just open a workbook and hit refresh? And they say, well, I wonder if I could get it to open automatically. And yeah, and maybe I can do more than one file. Maybe I can do them all together. And then, yeah, you just sort of get, this is that curiosity and the journey that you end up going on. I mean, I certainly didn't have this in my mind when I started this. But as I came up with new problems that needed to be solved, you start to think laterally about how can I solve this problem, and that's where I ended up. So, and this, coming back to something that you said up front, Alice, and that is that, find something that you're interested in and passionate about, and if you invest some time on that, you actually learn a lot as a result. Now, I'm doing this because I care about it and because I'm interested and I want to share with other people. But as a result, I've learned a whole lot of new techniques that I'm going to use for my paid job and will add me benefits. So it's not like you're just doing it for nothing. It's part of your overall growth journey, I think.
Yeah, definitely. And I guess working with different data sets, different challenges, if people typically work with only one type of data, you only see a small section of what you can and can't do in Power BI. So I think it's always really good to kind of expand your horizons and have a look at new data sets and things that you're interested in as well.
Absolutely.
Awesome. Oh, thank you so much for sharing not just your report, but lots of these cool tips. I love that one in Power Query as well. That is so frustrating when you have load from folder and you get heaps of the queries. So just small things like that, just so valuable. Got lots of nice comments in the chat as well. Yeah, everyone's loving it. So thank you so much for taking the time to share.
Thanks for your interest, Alice, and yeah, inviting me along. I appreciate it.
Yeah, no, of course. I've just got a couple of just slides just to close us out, because I think this is the last session that we've got for the year. So just to recap, if anyone is keen to watch or share this session, we'll share it on our blog and YouTube channel. If anyone is keen to present at a future session, we're always looking for different speakers. You don't have to present for an entire 45 minutes or an hour. You could do a really short presentation as well. Please reach out to us. And just wishing everyone a safe and happy Christmas festive period. Hopefully everyone has a chance to catch up with lots of family and friends and really take a nice and relaxing break over this period as well. So thanks everyone for dialing in today. It's really good to see lots of new people, as well as a couple of the regulars here as well. And yeah, thanks again, Matt, for taking the time to share all of those really interesting analysis that you can do in Power BI.
Okay, thanks all. Thanks, Alice. Thanks, Daniel.
Thank you.